Okay, so today we're going to talk about if statements. So now our code is starting to get a little more complicated in a good way. So it's allowing us to make choice within our code. So the way we make choice is we use if statements, and we need to know whether or not things are true or false. So we use them as Booleans. We have these 6 relational operators. They are less than, greater than, less than or equal to, greater than or equal to, equals, equal to, and not equal to. Now I want you to notice the last 4. The first 2 are pretty normal. The last 4, because the computer doesn't have like a little line underneath it, like we would see in math, we just write less than or equal to, greater than or equal to. And now this one is one that a lot of people make a mistake on, this equal to here. And the reason why people make a mistake on it is because a lot of times they'll just put 1 equals sign. And I want you to remember that's why we use the word becomes when we use 1 equals sign. Like x becomes 7 if we have like x, what we would say in math, x equals 7. Here, this is becomes. If we want to ask if something x equals 7, we say x and we use equals 7 to test whether or not it's equal. And it will, again, give us a Boolean. And then lastly, to test whether or not something's not equal, we use the exclamation point here for not. Okay. Relational operators that are used to compare two variables, values, expressions. They can even be used, well, we'll talk about using them in objects in a minute, but usually 2 values, variables, or expressions. And the result is either a Boolean, so true or false. Now, we talked about, I just mentioned equals, and we've talked about a little bit regarding strings. So why do we use equals versus equals? Like, what's the difference between them? Well, equals is a method. It's usually overridden by the object class. And remember, this is the class at the very top of the hierarchy of Java. So it's the biggest root class. Everything else comes underneath it. Okay, and it tests equality of objects based on one or more specific attributes of a class. We can write our own .equals methods, and a lot of other classes have them. So for instance, like the string class has them, and it uses it in order to test the contents of the string. So do both strings both have the words hello? Okay. If we use equals with objects, we're testing for aliases, which means whether 2 identifiers are pointing to the same object. Okay. And we talked about that last chapter. But it can also be used to test if an object is null, meaning it's not initialized. So here, like, let's say we said string x becomes hello, and string y becomes hello. Now, these are both string literals, which means they point to the same object, okay? So if I said x equals y, that would give me true. That's not always the case. Let's say I had string z becomes new string hello. If I want to test the contents of both of those strings, or let's say x with z, I would say x dot equals z, okay? And this would give me true. If I said x equals z, this would give me false, because they are 2 different objects, since this one is created with the new operator. Okay, so it really depends on if you want to use equals or .equals. .equals is basically for comparing based on some sort of attribute of the object. Equals is used with null specifically, and also to see if we have aliases or if things are pointing to, if identifiers are pointing to the same object. So if I want to write a .equals, this is the student class we've been looking at. over time. So let's say I want to use the student class. So let's say I'll say public, and it's going to return a Boolean, and I'll say equals. And maybe I'll say, if we're going to override the object class, we would technically put the word object here, the type object here, but I'm going to simplify this for you all and put student, and we'll put it as other. So let's say I want to compare two students based on, let's see, we'll think about how we can sort students. So maybe they're equal if they have the same ID number. Okay, so then we'll have to look up here and see what the ID number is. It's a string. So we can just say return this dot ID num. So this is saying this object's ID number dot equals other dot ID num. The keyword this here is oftentimes used here when I want to compare two different things. If I have one student and another student, this refers to the student that you're calling the method on dot equals, and the other one is the one inside the parameter. So let's say I have Billy here and Kelly, but let's say Billy and Kelly have the same ID number. So I just changed them. And then let's say we said Billy. Oh, we'll print it out. Well, we'll say Boolean. And then we'll say same becomes Billy dot equals Kelly. And then we'll say system dot out dot print line it is plus same that Billy dot get name, and then try and get this all so we can see it. I forgot to put parentheses here. Billy dot get name, and Kelly dot get name have the same ID number. So now, given our dot equals, and that's how we compared them, actually, let's start with them being not equal to each other. So we know that they have two different ID numbers. So let's run this thing. Billy. And let's say the expected graduation year is, I don't know, 2020. And then Kelly, 2020. This was from code earlier that I did. All right, so here, the student email was from the last section when it did the student email for me. This formatting is a little bit off. I should put a space in between and before have. So it is false that Billy and Kelly have the same ID number because now they don't. But let's change it so that they do. And remember, I use dot equals because these are strings and I'm trying to compare the contents of the strings. So Billy 2020, Kelly 2020. So now it is true that Billy and Kelly have the same ID number. Okay, here, since Billy is the one I'm calling it on, where I say this refers to Billy, and other refers to Kelly, because Kelly is inside of the parameter here. Okay. The other thing that's important here is these are strings. So in order to compare, I wanted to see whether or not these strings were equal, meaning I wanted to know whether or not their contents were equal, not whether or not they pointed to the same string. So in this case, I used the dot equals for string. And you can compare them on any way you want. You could, like, let's say we wanted to compare them by GPA. We could say this dot GPA, and GPA is a double. So now instead of using dot equals, I'm going to use equals equals, because I use that to compare numbers and chars and primitive values. And I'm going to say other dot GPA. And now I'll change this over here, have the same GPA. So I'm going to change this back. The student's name is Billy, 2020, Kelly, 2020, graduation year. Oh, that's right. So it is false that Billy and Kelly have the same GPA because they don't have the same GPA, but let's change them to have the same GPA and we'll see what happens. Now again, I used equals equals because I was comparing two doubles. So Billy, 2020, Kelly, 2020. And then you can say it is true that they have the same GPA. Just as another, why is it running this email? And why is it having me type things in? In the constructor here, I called in the last section, remember we did input and output, so I called in the user to type in the name and then to type in the graduation year. And then I had the toString here. This is the toString printing this out. And so when I'm inside the toString here, it prints out everything, including assigning the email address. Okay, so it prints out their name, right? See, we see their name, their ID, their GPA, and their email address. And their email address was the first name and the last name. I hadn't typed in the last name, but had I typed in the last name, it would give me the last name start, the first name, the first letter of the first name, the last name, and the graduation year at sarahhs.com. So if you'd like a review on how to assign, how to use string methods, you can look at the last video because that talked a lot about input and output and how to use substring and index of to assign an email address. Okay, so why do we want to test for null? Okay, so if we want to call a method on an object, but the object is null, we're going to get this thing called a null pointer exception, and we don't want those. The reason why we don't want those is because they immediately end the program. All right, and it's called a runtime error. It only happens when the computer's running. Okay, but if we test for null, it allows us to deal with the possibility of this so we can kind of use a get around, so we can not have our program quit. We'll talk about that a little more in a minute. So we also have logical operators. These allow us to test more than one statement at a time. So if I want to test two statements or more, I can use and, or, and then not is also considered one, though we talked about that a little bit before. So the not operator just changes a Boolean value to its opposite. Not false is true, not true is false. So in this case, if we negate a single expression, it distributes the not into the relational operator here, and this becomes not equal to. So this not here to the less than completely negates it to greater than or less than. So it includes the greater than option and the less than option, and not greater than or equal to. Oh, I said greater than, I meant here. This not here into the less than gives us the greater than or the equal to option. This into the greater than or the equal to, the complete opposite of this would be the less than. So just be aware that if you are putting a not in with I guess what I would call a single sign relational operator, you're going to get two of them out if they're less than or greater than. And if you are going to go with a greater than or equal to or a less than or equal to, you're just going to get one out. All right. So the AND operator, which we have shown on we use on the computer by saying the ampersand. Okay. True and true gives us true. True and false gives us false. False and true gives us false. False and false gives us false. The big thing is, if you have one false, you immediately get false. Okay? So, this first one here, and actually the same would be true for the second one. If the first half of the expression is false, the second half will not be evaluated, and this is called a short circuit evaluation. This is key for us. This is where it helps us out. Okay? When we test for null, it allows us to skip over a whole block of code if an object is not initialized, especially code trying to call methods on an object, which is super helpful to us because we don't want our code to end. So, here's an example. I just declared here a string called x. X is not initialized. So, this is important. It's not initialized to the empty string. It's just not initialized at all. It doesn't exist in the computer yet, okay? The computer expects it, but it's not initialized. So, we can say if x is not equal to null and x.length equals 5, x becomes x.substring 4. But here's the thing. It's going to look at this piece first. If x is not equal to null, well, in this case, x is equal to null. That's its default. And so what's this going to be? This is going to be false. Because, I'm sorry. Yeah, this is going to be false because x is equal to null. And so then it's going to skip over this. So we're not going to get a null pointer exception. It won't actually do this. And it won't actually do this code either. It's going to say, oh man, x is equal to null. All right, this thing is false. I'm going to then continue on to my code down here. It skips the entire block. All right. Now we have the OR operator as well. That's with the two lines here. It can be found like right under, on my Mac, it's like right under the delete. It's shift backslash. And again, we have true and true is true. True and false is false. False and true is true. False and false is false. We also have short circuit evaluation for this. For these two, as soon as we get a true, it's going to go into the actual whatever it evaluates to true. So if you had it in an if statement, it would go right in there. Okay? So it's another example of short circuit evaluation. Now we also have a special law here, what's called De Morgan's Law. De Morgan's Law deals with these logical operators if we have a not on the outside. So the way I like to think about it is I think about it like the distributive property. This not here gets distributed to the A, or if this is in a relational operator, it'll swap the relational operator. Then it changes that and to an OR to the opposite, and then it gets distributed into B as well. So it's key that you remember to distribute it to every single little thing. It's used to negate compound Boolean expressions. And let's do an example here. So, if I am going to use this one, I go like this, it's going to go here, here, and here. So not x is less than or equal to y. So that's going to be x is greater than y, because that's the complete opposite. Then I change my and to an or. And I'm also going to change this as y is not equal to, or is not greater than 5. So then y is less than or equal to 5. So that's completely negating it. Now, in this case here, we can assume that C and D are Booleans. So this one's a little bit easier. We get C and not D, because, oh, I'm sorry. I was not paying attention. This one is asking us to actually, and this happens too, where they want you to put the not in, and then take the not out. So if it looks like this, and there's no parentheses, and they're using you to do De Morgan's Law, they're asking you to do De Morgan's Law, they want you to actually factor out the not. So we're going to factor that not out, and that not C will become C. The or becomes an and then D becomes not D. So you have to be able to do it both ways, where you distribute in and factor out. You can assume that C and D are Booleans here. So you can try the other two on your own if you would like. Here are some other examples. Okay, so these are a little more complicated. I'm going to walk through these. So X is false, so then I have false and Y would be true, so not true is false. Or true and true. So now I get a false, because false and false gives me a false, or true and true gives me a true. And so that's going to give me, if I have one true and an or, it gives me a true. All right, let's look at the next one. This is false or true and false. So I go left to right. False or true gives me a true. And false, that one gives me true. And false gives me a false. As soon as I see one false with an and, I get a false. Okay, with the next one I have false. And let's see. True or false. So false and true gives me a false, or false gives me a false. And then this last one is De Morgan's Law, so I'm going to go like this. Not X and not Y or Z. Not X would be true, and not Y would be false. So I did the opposite of these two up here. And then I say or false. So I get a true and false gives me a false, or false gives me a false. So the best way to do these is just to practice them. The way I like to remember it is as with an and, as soon as I get a false, it's false. With an or, as soon as I get a true, it's true.